Welcome to day 2 of our Unit 2 Logarithmic Functions. Today we're actually going to focus on talking further about the inverse of functions. Yesterday we talked about what the graphs look like and the table of values look like, the relationship between those things. So we're going to explore that further, and we're going to then look at being able to rewrite an exponential expression in its logarithmic form and vice versa. So that has to do with inverses. By the end, you should also be able to use your calculator to evaluate logarithmic expressions, and I should have added with a base of 10, but we'll get there. All right, first of all, the inverse of a function. What we're talking about there is, yesterday we found graphically your inverse was just a reflection of the original function in the line y equals x. And as far as the table of values went, we found that if you just interchange the x with the y, so the y of the original becomes the x of the inverse, the x of the original becomes the y of the inverse, that's how we can get our table of values. We're going to focus a little bit today on getting the equation itself for the inverse if we know the original equation. All right, so we're going to type a few things in here. First of all, the inverse of a function. If f at x, so f with your brackets, so function notation, if f at x is the function, we do have special notation for it. Its inverse is denoted by, or has the notation of, now, I don't know if I can do this on my iPad. I think I can. I think I can. All right, let's see. I want f, and then we're going to put it like a negative exponent, or negative 1 as an exponent that comes right after the x. So let's see if I can do that. Oh, sweet. I managed to get that. And then the question is, can I get back down to where I want to be? Oh, look at that. Luck is on my side. I better go buy a lottery ticket. So there we are. So if f at x is the function, its inverse will be denoted by f, the inverse function of f. And so that has a negative 1, not to be confused with, and I'm going to use my pen for this, not to be confused with f at x to the negative 1. So remember our negative exponent rule? That, on the other hand, to the negative 1 on the outside of that, that is the one that means 1 over f at x, that negative exponent rule. These are not the same. They don't mean the same thing. So the placement of that exponent negative 1 makes a difference. So be sure if you're talking about the inverse, you put it right after the f and not on the outside of the x. All right, so graphs, we're going to just summarize what we know about graphs, about tables of values, and then we're going to talk about the equations and how to get the actual equation for our inverse. And I'm just going to type that up and get that in here. All right, so graphs, I've written here, the inverse of the function is a reflection in of the original function in the line y equals x. Now with that, this is kind of new, we didn't talk about this yesterday, but the domain of the original function becomes the range of the inverse, think switch x and y, and the range of the original function becomes the domain of the inverse. Again, you're switching the x with the y. So when we talked about tables of values, we talked about the roles of the x and y being interchanged. So again, that's why this domain and range is interchanging between the two. So the x-coordinate of the original function became the y-coordinate of the inverse, and the corresponding y-coordinate of the original function became the x-coordinate for the inverse. All right, so that exchanging of x and y is really important, and that's going to help us with our equation part. So to get the equation of your inverse, we've got a couple things going on here. First of all, if you have function notation, you want to change that f at x or the g at x or the h at x or whatever you have at x, just replace it with y, straight up y. Then you can replace the y with x and the x with y. We're doing step B, we're interchanging the x for the y in the equation. Then you take that and get y by itself, because y will now be mixed in with the other functions, the function stuff that's going on. And then once you get the y by itself, you're ready to replace the y with that notation of f at negative 1, the inverse function of f, which is f with an exponent of negative 1, but it's not really an exponent, it's just communication, of x. So let's try that with some examples here. Now, you have the privilege of putting that information in front of you as we're doing this. All right, step number 1, or step A, I guess it was, determine the equation. We want to take this function notation of f of x, we're going to replace it just with the letter y, because that really means just y equals 3x minus 5. So step A right there. Step B is to interchange the x and the y. So where I have y, I'm going to put x, and where I have x, we're going to replace it with y. Next step is we want to get the y by itself. We're going to solve for y just like it was a regular equation that we've talked about before. I would add my 5 to both sides here. So we're going to get x plus 5 equals 3y. And then to get the y by itself, it's multiplied by 3, so let's divide out the 3. So now I've got my equation. I'm just going to rewrite it in the other order. I'm going to put the y first. Y is equal to x plus 5 all divided by 3. So yesterday when you did the first table of values, you had the original function being a linear function. When you did the inverse, it had this kind of format, which is also a line. It's just got a different slope. But you could try that with that first table of values and the equation I gave you, just to make sure that the inverse I showed you was the correct inverse. So now you know I didn't just pull that out of my butt. I know exactly where that came from. All right, so f prime at x then, not f prime at x, the inverse function of f at x is now equal to x plus 5 divided by 3. All right, g at x. So try those steps there. First, replace that g at x with a y, and then interchange your x and y, and then solve that for the y, and then use your function notation there. So we're going to undo the plus 2 by subtracting 2 from both sides. So we get x take away 2 equals y squared. And then to undo a square, we talked about the inverse operation to squaring something with square rooting it. Now, I am only going to look at the positive square root to this. Technically, when we square root, there's 2 answers. There's the positive and the negative. If I put both of them there, it won't be a function. It's not going to pass that vertical line test. So I'm only going to take the positive part to that. And we would have y being equal to the square root of x minus 2. And that means then the inverse function of g at x, so the inverse function of g at x is equal to the square root of x minus 2. All right, any questions? Oh yeah, this is a video. You can't ask those, never mind. All right, moving on to the next. H at x, we've got y is equal to 3 to the exponent x. And then we're going to replace the x with the y and the y with the x. X is equal to 3 to the exponent y. And then here's where life gets difficult. We don't have a way to get that y by itself. And that's where this next part comes in. It says, what is a logarithm? So the logarithm is the inverse function of an exponential. It's the inverse. So if we look at the basic exponential function, we had y equals 3 to the x. I'm going to make it more generic and say y equals b for base to the exponent x. So y is our answer. Y is the answer. I'll just use the word answer. B is what we call the base. It's the bottom of our exponent, or our power. It's what's getting the exponent. And of course, x is the exponent. So if I want to write that in its inverse, okay, so this will be the inverse. If I flip that over to its inverse, this is what it looks like. Okay, and trust me on this for now. What it's going to look like is x. So the exponent is equal to log. So if you look on your calculator, you should have a button that says log, log. It's short for logarithm. It's the function, the logarithmic function, just like sine is a function. You're always doing the sine of something. We're doing the log of something. And that something would be the answer, which is y, and it's also known as the argument, but we also have to specify what the base is. So our base is a subscript. It's little. It goes downwards there. Instead of an exponent, it's the opposite. It's a subscript. So think like y2 minus y1. The 2 and the 1 were subscripts. That's what the b is, the base. Oops, and I put an x and I meant to put y there. Can't talk and write at the same time. There we go. All right, so how this matches up then is this now is solved for the exponent. The exponent is here, and we have this new function, this new thing that is the opposite of an exponential. The b, this thing, is still the base. So in my C example, the base was 3. So my base number would go there, the 3 would go there, and the y is what we had as our answer. So if we relate this back to the example we were just working on, part C there, I want to get the y by itself here. Okay, the y is my exponent, so this is going to be a little bit confusing because my x was the exponent in this, let me see if I can color it. This part right here, the x was the exponent, but now I've got y being my exponent, so it's kind of backwards. There we go, good. So let's see what this is going to look like. And we'll do some examples to get more comfortable moving back and forth between these things. So this means the exponent, which in this case is the y. The y will equal the log. The base was 3, so I'm going to have a subscript 3. And my answer was the x. And my x goes there. So that means my inverse function of h at x is equal to the log of x with a base of 3, or log base 3 of x. Pretty cool. Okay, now we're going to have to work at how our calculator works with these things, but not to be concerned yet. We'll get there. All right, the other thing I'm going to write in here with y is also known as our argument. So I'll talk about the argument, and that's just talking about that answer piece that's right here. Sometimes you'll see that in brackets, but it is the log of that value, that argument there, with a base of b.